I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss derivative of inverse functions related to trigonometric functions. So we'll actually find the proof for the derivatives of inverse trigonometric functions. It is a very important part of calculus, and I'll make it very simple and easy for you to understand. That is the whole objective. So as you can see on the screen, we have all the basic formulae related to derivatives of inverse trigonometric functions. We are going to prove them one by one. First one, d dx of sine inverse x is 1 over square root of 1 minus x square. D dx of cos inverse x is minus 1 over square root of 1 minus x square. D dx of tan inverse x equals to 1 over 1 plus x square. D dx of cosecant inverse x is minus 1 over x square root x square minus 1. D dx of secant inverse x is 1 minus x times square root of x square minus 1. And d dx of cotangent inverse x is minus 1 over 1 plus x square. So you need to remember them most of the time, but soon you will also understand how we can actually remember them. Not only that, we will also see how we can prove them very easily. Well, to prove these formulae, you need to understand few things. One of them is the inverse function itself. So when we say y is sine inverse x and y is a function, in that case it is important to understand that sine function is periodic. That is to say that if I draw a horizontal line, in that case it is going to cross the function at a couple of points. That means its inverse will not be a function. To make that a function, we have to restrict the domain, right? So for sine, the domain is restricted as minus pi by 2 to pi by 2. So that is a restriction in the domain of sine to ensure that the inverse of sine is also a function. For cosine, this restriction is from 0 to pi. For tangent, it is from minus pi by 2 to pi by 2. And of course, you cannot include pi by 2 since we have vertical asymptote for that. So once we have done this restriction, then we find the inverse to be a function, and that is the interval in which we are going to work. Well, depending on the question, this interval can be changed, right? So remember that part. So we are flexible about it. Flexible to work over different intervals. All that you learn while learning about inverse of trigonometric functions. Perfect. So we are not getting in there. However, you have options, correct? Right. So that is one thing which you need to know. And what else? Definitely, you need to remember the derivatives of trigonometric functions themselves. As you know, the derivative of sine x is cos x is minus sine x, tan x is secant square x, cosecant x is minus cosecant x, cotangent x, secant x is secant x tan x, and cotangent x is minus cosecant square x. So this is another very important information which should be there with you when you work with inverse trigonometric functions. Make sense, right? So I'd like you to make a note of this on your paper, put it on a side, all these things, and then begin to work on how do we find the derivative for inverse function. In the next video, we'll take up examples related to what we are going to derive here. We are only going to derive the formulae and understand the strategy in this particular video. Correct? Now, you also know what is an inverse function in general and how do we find derivative of inverse function. Let's have a look at that also. Now, here we're talking about general inverse function, right? As I said, inverse function. Okay, so in that case, if we are given f of x and g of x are inverse of each other, we'll for the time being take g of x as inverse of f of x. And what you need to find is the derivative of g of x. Now, g of x is inverse of f of x. So these are inverse functions. How do you, in general, find the derivative of inverse function? That is what we are going to look at now. And then we'll apply these strategies on trigonometric functions, right? Okay, so if they are inverse functions, in that case, f of g of x is going to be x, correct? By definition, we know these are inverse functions, right? Therefore, f of g of x is going to be 1. Now, so this is like saying we want to find derivative of inverse function, right? That is what we are trying to say. Now, if I take the derivative on both the sides, in that case, applying the chain rule, we get that the derivative of f prime g of x times derivative of g of x is equal to 1 because derivative of x is 1, right? So this is what we get if we take derivative on both sides. With respect to x, right? So you get this expression. And from here you can isolate what is the derivative of inverse function. You get the idea? So derivative of inverse function is actually equal to 1 over the derivative of the function at g of x. You get the idea? G of x means value of x at a. So what I'm trying to say here is we got a general formula here. You understand? So we could write this as inverse because g of x is basically the inverse of f of x, right? So inverse of f of x derivative is equal to 1 over derivative of f of inverse x. So that is what we get. And what does it really mean? If I have a point AB on g of x, then BA will be on f of x, right? So we are saying at this stage, taking at any particular point, derivative at A on the inverse function will be 1 over derivative at B on the other function if A, B are the coordinate points. You get the idea. So that is what is inverse derivative. Each value becomes reciprocal of one another, right? So we are saying that if the gradient at a point AB on the function, so we are saying in this case that if we have a point, let's say, let me just sketch this here. Let us say we have a function which is kind of like this, and its inverse will be another function which will be reflected on y equals to x. Let's say something like this. And if we have a point AB here, we're talking about inverse. Let me take point AB on the inverse. In that case, that point will be BA, right? You get the idea? So what we are trying to say is the derivative of this particular point, which is, we are saying GA, is actually the derivative on the original function, but at B, because B becomes the x there. They flip. Perfect. That is what we're trying to say. Correct? We'll elaborate on this with trigonometric functions, and then you'll get an idea. Now, let us begin with our differentiation rules and figure out how do we prove that derivative of sine inverse x is indeed 1 over square root of 1 minus x squared. So now, to prove this, let us say y is equal to sine inverse x. That really means that sine y is equal to x. Now, if I differentiate with respect to x on both the sides, I get what? I get d dx of sine y equals to d dx of x. Now, doing the implicit differentiation, derivative of sine y will be what? Will be cos y times dy dx. And derivative of x is 1. And that gives us that dy dx is indeed equal to 1 over cos y. Make sense? Dy dx is 1 over cos y. You see that? So if you look into the proof which we were just talking about, does it connect? Now, let's highlight. You know what is the derivative of sine x? It is cos x. Perfect. So what is the derivative of sine inverse x? Derivative of sine inverse x is reciprocal of cos x, but the x value becomes y because it is the inverse function. You get the idea? The point xy becomes yx. Does it make sense? Take a moment to understand this step. Very beautiful, right? So we got this. So basically, derivative of sine inverse x is 1 over derivative of sine x where x equals to y because it is for the inverse function, right? So we get our answer. Now, how do we write cos y in terms of x? That is what the second part is. Now, if we are saying y equals to, if we are saying sine y equals to x, it really means that, let's write down sine y equals to x. That means in this particular triangle, if we have the angle y, then the ratio opposite side over the hypotenuse is x. Means opposite side is 1, x and hypotenuse is 1, correct? That is what it means. So we have a related triangle. Now in this right angle triangle, clearly, the third side, using the Pythagorean theorem, will be x, where hypotenuse squared minus x squared, square root. So we get square root of 1 minus x squared. Now in this particular triangle, can you tell me what is cos y equals to? Cos y is adjacent side over hypotenuse, right? And clearly it is equal to square root of 1 minus x squared, hypotenuse being 1. So that is what we are going to substitute now for cos y. And what do we get? We get 1 over square root of 1 minus x squared. Does it make sense to you? Simple as that, right? So we could have written directly also the derivative of sine inverse x as 1 over cos y. And then making the triangle, we can write our expression, which is given here. You get the idea. Let's do it for cosine, right? So the whole derivative, which I just did for you, is nicely typed out here. I'd like you to take a moment and understand once again how we got our result. Y is equal to sine inverse x. That means sine y is x taking derivatives. Cos y dy dx is 1, dy dx isolated, 1 over cos y. And from the triangle, if you look at this triangle, where we are representing sine x, right? Sine y equals to x. So if this angle is y, opposite side being x, hypotenuse being 1, adjacent, will now become square root of 1 minus x squared. And therefore, what is cos y? Well, cos y therefore is square root of 1 minus x squared, right? So from this triangle, we get what cos y is. And that value is substituted to get this result. Perfect. Now let's look into the cosine derivative, right? We'll follow exactly the same steps. In fact, the same steps will be followed for all the 6 trigonometric inverse functions, right? So we have this, let y equals to cos inverse x, right? So that means cos y equals to x. So we have made this diagram now. Cos of y is equal to x. That means x becomes the adjacent side, hypotenuse being 1, and based on that, we get the opposite side as 1 square minus x square square root. Is that correct? So that relates to this triangle. Right? So let me draw this arrow so that you understand. That is how we linked it. Now we are going to differentiate both sides with respect to x. And so what do we get? Derivative of cos y will be minus sine y. dy dx. And derivative of x is 1. Perfect. So we can now isolate dy dx. And we get 1 over minus sine y. Purposely, I am writing it here. You see that? Again, derivative of cos x is minus sine x. Minus sine x. And we got this minus sine y in the denominator. Perfect. Now what we are going to do? We know what sine y is. From here, we can see what sine y is. Sine y is opposite side of square root of 1 minus x squared. So that is what I am going to substitute here. And I get negative value, of course, of square root of 1 minus x squared. You see that? And that is how we find the derivative of cos inverse x. Makes sense? So simple. Exactly these steps have to be followed, and you should remember what the derivative of the function is to find the derivative of its inverse, right? Now let's look into the nicely typed out solution. As you can now see, if I want derivative of cos inverse x, it is equal to reciprocal of, what is the derivative of cos x? Minus sine. And since we are talking about inverse function, minus sine y. You get the idea. So you could directly write down this answer, and then, if y is equals to cos inverse x, then cos y is x. Make your right angle triangle with cos y equals to x. The angle being y, you get x as the adjacent side and 1 as the hypotenuse. Opposite side being 1 minus x squared, right? So remember one thing, all angles are in radians, right? So we are actually working in radian measurements. So whenever we talk about calculus and trigonometry, that is the default unit, right? Okay. So does it make sense to you? Perfect. So I think now the connection has been made. So when we talk about tan inverse x, in that case, can you tell me what the result is? So we know we are trying to find what is the derivative of tan inverse x. So this is what we need to find, correct? Using our concept, we can also say, well, let me write y equals to tan inverse x. That means tan y equals to x. Now, tan y equals to x gives me a right angle triangle where the opposite side is x, adjacent is 1, hypotenuse being 1 plus x squared square root. Correct. So that gives us this triangle. Now, what is the derivative of tan inverse x? Well, the derivative of tan inverse x should be equal to reciprocal of derivative of tan x, where on the coordinate point we have y. So secant square x is the derivative. So we get secant square y as the result. You get the idea. Now we know what is secant y. Secant is reciprocal of cosine. Since secant is reciprocal of cosine, it should be 1 over square root of 1 plus x squared, right? So from here, we can see what secant is, right? So we know secant x is equal to square root of 1 plus x squared. And secant square x is equals to 1 plus x squared. Substituting this value, we get our result. You get an idea. So that is how you could interpret the derivative. Otherwise, follow the steps which we had been doing. That is the actual way of doing it. Both are correct. Okay. So once again, when we are talking about derivative of tan inverse x, we can write y equals to tan inverse x. It really means tan y is equal to x. That gives you the right angle triangle with the sides x as the opposite side, 1 as the adjacent, and calculate the value of hypotenuse using Pythagorean theorem, square root of 1 plus x squared. Now, take derivatives on both the sides. So differentiate with respect to x on both the sides. We get tan y derivative is secant square y, dy dx equals to 1. Isolate dy dx, we get 1 over secant square y. Substitute the value of secant y from here, right? Secant y is square root of 1 plus x squared. And when you square it, you get 1 plus x squared. Perfect. So that is how you get the derivative of tan inverse x. Got it? Correct. Now let's move on to find the derivative inverse of the secondary ratios. Correct? So here, as you can see, we now want to find derivative of cosecant inverse x. So let y equals to cosecant inverse x. That means that cosecant y is equal to x. Now based on that, make a triangle, right? So here you have y as the angle, right angle triangle. Cosecant is x means opposite side being 1, right? It is 1 over x reciprocal. So it will be x over 1 as shown here, right? So the adjacent side will be x squared minus 1 square root. And when you differentiate both sides, what do you get? You get derivative of cosecant x, and this is 1, and isolate and get the result. Otherwise, you know the shortcut method, right? The shortcut method is that dy dx is basically equal to 1 over derivative of this function, which is minus cosecant x cot x. You get the idea. Reciprocal of this derivative itself. And now from here, substitute the values. Perfect. So from here, substitute the values. So we know we are doing the inverse, so we will write here minus cosecant y cot y. Correct? We are doing the inverse. So on the function, x becomes the y. So that is why we get cosecant y cot y. And now we know what cosecant y is. Cosecant y is x, right? That is given to you. And what is cot y? Cot y, you can see from here, is reciprocal of tan, so which is square root of x squared minus 1. You can substitute these values and get your result. You get the idea, right? So it is negative of 1 over x square root of x squared minus 1. Is that clear to you? So this is a very easy way of remembering, since you know what the derivative of cosecant x is. Otherwise, we'll follow a standard method, which is shown here. So y equals to cosecant inverse x means cosecant y is equals to x, and that gives you the right angle triangle where y is the angle we are talking about, and x becomes the hypotenuse with the opposite side of 1, adjacent being square root of x squared minus 1. Taking different derivatives, both sides with respect to x, we get derivative of cosecant y will be minus cosecant y cot y dy dx equals to 1. Dy dx being equal to minus of 1 over cosecant y cot y. Substituting the values from here, the triangle, we get our result. Perfect. That becomes our strategy to find the derivative of any inverse function. Perfect. Now let's look into secant. So following the same steps, you could write y equals to secant inverse x. So we have secant y equals to x. Differentiate with respect to x on both the sides. So secant y derivative is secant and tangent, right? So we get secant y tan y dy dx equals to 1, and dy dx is equal to the reciprocal 1 over secant y tan y. Simple as that. Perfect. And from this triangle, you can find both the values. Secant y we know is x, and what is tan y? As you can see from the triangle, tan y is the opposite side, which is square root of x squared minus 1, since the adjacent is 1. Is that clear to you? Perfect. So I've shown you the same derivative, how simple it becomes. Now you're getting the ideas, right? So that is how you have to figure it out. So that becomes your proof. Perfect. Now I hope you can apply this concept and figure out what is the derivative of cot inverse x. Perfect. Let us prove it. So follow the standard method. We can write this as y equals to cot inverse x, correct? That gives us cot y, cotangent y is x. And from here, make your triangle. And cot y is basically x, means this should be x, right? And that should be 1, right? So that is how you're going to get the triangle. Perfect? Remember that. And also remember, what is the derivative of cotangent? You have to remember, that's why it's not written here. We know derivative of cotangent is minus cosecant square x. Now take derivatives on both the sides. So we have made the triangle already. And now let us differentiate with respect to x. So we get what? We get the derivative of cotangent y as cosecant square y dy dx equals to 1, and dy dx will now be equal to negative 1 over cosecant square y. And what is cosecant square y? So from here, let us find what cosecant y is. Well, cosecant y is the hypotenuse over 1, which is 1 plus x squared square root. Perfect? So we're going to substitute this here. So we get minus 1 over 1 plus x squared, the square of cosecant y. Do you see that? So that is how we are going to find its derivative. Perfect? Now here is the typed out result for you, and we made a mistake here. When we say cot y is equal to x, that means cotangent is the ratio of adjacent to hypotenuse. So we get this as x and that as 1, right? So x and 1, and then we can get the derivative. Perfect. So we have derivative of cotangent y as minus cosecant square x, substitute the value, get the result. You get the idea. So with this, we have done the derivative of all inverse trigonometric ratios. I hope the concept is absolutely clear. In case you want to learn from me, you can always send an email on the address given. And if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.